So our next session comes from Scale Computing, and presenting for Scale Computing is Alan Conboy from the Office of the CTO. Alan, welcome to the EcoCast.
Hey, thanks. Glad to be here.
Yeah, take it away.
All right. Well, let's go ahead and get this kicked off. And I'm going to take a little bit of a different spin here. Breaking the chains that bind you. Now, the reason behind this is simple, and it's actually buried in the title of this EcoCast. Data center to the cloud, optimizing and monitoring IT infrastructure. Now, that seems like it should be a fairly straightforward thing. But the fact of the matter, it isn't. You know, brief history lesson here. How did we get to where we're even looking at tools for our tools to do our jobs? Well, it has to do with the technology swings that happen in 20-year cycles, going from mainframe back in the day up through distributed and client server that we all cut our teeth in, and re-centralization into the cloud, and then redistribution. You see, redistribution really comes down to redefinition. Okay? The place where business is done has changed. And it's called edge these days. But what that really means is you're literally needing to be able to optimize, monitor, command, and control all the way from the edge to the fog to the core to the cloud. So let's talk about what really has changed here. Because quite frankly, it's not 2015 anymore. It's not 2019 either. As a matter of fact, the way business is done today would be almost unrecognizable to somebody a decade ago. The reason why is pretty straightforward. Almost everything has changed. You see, where business is done, it's not in the halls of the data center. I don't know about you, but I don't recall having a business meeting or a contract evaluation sitting next to racks of gear in somebody's data center, much less the hallowed halls of Amazon or Azure. You see, business is done where people actually do things. Today's world, we call that the edge. And I would posit that the edge really is the data center in its new expression. The data center, as we've known it for years, it's almost become the fog layer. With the cloud, it's absolutely still there and has its purpose. Here's the thing. The mass migration to the cloud, as you heard before in some of the intros and presentations coming up to this point, the mass migration to the cloud didn't really work out terribly well for everything. And it became obvious that a hybridized world, not to reuse that overused term, is the one that makes the most sense. Putting the applications that need to be in the cloud in the cloud. You know, email's gone up there and it's not coming back. But real-time applications, monitoring, PCI compliance, retail operations, etc., those don't happen in the data centers anymore. They happen at the edge. So what you're really talking about as you talk about optimizing and monitoring IT infrastructure is how do we handle command and control with pieces of IT technology and applications placed where they actually need to run. And the truth of the matter, well, it has to do with tying it all together. Now, let's expand on that a little bit. Okay? Today's world is a Tower of Babel. And what I mean by that is you have all of these disparate pieces of technology designed essentially in isolation from each other, trying to be glued together in ways that often just don't fit, can't even be made to fit. Heck, that's part of why we're having this discussion of how on earth do you do this? Well, the truth of the matter is it shouldn't have been done this way. But it was, and here we are. Okay? This history of how we got to where we are is why, as IT folks, we spend half our lives finding or building tools for the tools to do our jobs. It was never designed cohesively from the ground up. But that's being fixed as we speak. Okay? You see, when you take a cohesive approach, a top-to-bottom stack approach, to all of the pieces and parts and layers that go into a true top-to-bottom, edge-to-fog to core-to-cloud solution to support business, to support any of our activities, you wind up with something that actually works together the way it should be, that includes all of the pieces that should have been there from day one, that knows directly how to talk and interact specifically with each other. But most importantly, doesn't require a meta upon meta of tools to interact with tools to interact with tools, but rather just works. So let's talk about that new data center, the edge, where people actually do things, where business actually gets accomplished. It's outside those four walls of the traditional data center. It's in the oil fields, in the dealerships, in the power poles. It's at the retail stores. It's in the home. Heck, in today's world, 40-some-odd% of retail activity takes place in the house. Well, let's face it, that's not exactly what you'd call the data center. Not even close. Every person attending this, they bought something on Amazon in the past week. They didn't get in their car and drive somewhere. So the edge, it's not the legacy data center. It's where business actually happens. But here's where that gets interesting. How do you handle that? How do you tie all of those pieces of the edge, the new DC, back to the core, through the fog, to the cloud? When you start to look at what the edge is, well, quite frankly, it's a pain multiplier. Why do we do it? Simple. Taking this approach has accelerated business at a level nobody anticipated even 5 years ago. But what do I mean by pain multiplier? Your average barista is not a VCP and a CCNE and a SNIA certified storage engineer, not a multi-cloud engineer. The same can be said of the store manager, etc. Every single event that can happen from a technology perspective at the edge is multiplied by number of sites. Tens, hundreds, thousands, tens of thousands of locations that are, shall we say, expert-free. So what that really means is an infrastructure built from all the way at that edge endpoint that runs on tiny devices, that handles the high availability, fault tolerance, that handles the traditional job of the IT admin in and of itself at these tens of thousands of locations, that frees up those admins to be able to do the things that actually move the business forward in today's new world. Rather than continue to exist in this meta of meta environments by taking a holistic approach to how infrastructure should have been done in the first place, things get to change. we start having this ability to implement infrastructure that anybody can implement, from the barista to the store manager to the field worker. It doesn't require rolling trucks. That's managed centrally across entire fleets. Everything from firmware updates to you name it. The key is adapting our businesses to work with how infrastructure actually needs to run today. Not trying to drag 2005 forward. The key to accomplishing that is holistically designed, holistically built, top-to-bottom stacks that run identically from the edge to the fog to the core to the cloud, whether you're talking about containerization, virtual infrastructure, doesn't matter. Legacy applications running right happily alongside the latest, greatest containerized applications, all managed from a single pane and made simple. See, the key to today's world and tomorrow's is simply this. Understand that business isn't going to happen at the core the way it used to. It happens where the rubber meets the road, and what don't you have at that location? You don't have the experts. So you need infrastructure that handles it for you, that self-optimizes. Efficiency at every level. Simplicity that means you don't have to have those VCPs and CCNEs and SNIA certified storage engineers in places where they simply don't exist. Now our platform, HC3, was built to do exactly that. Starting with things as small as the Intel compute card, Elements, NUX, all the way up through to the 1U, 2U, 3U, 4U gear that you're used to seeing, from the tiniest of the tiny to the largest of the large, fleet managed across the globe, that anybody can implement, that includes security, that includes survivability, that automates high availability and fault tolerance in a way that you just don't have to think about. That's what HC3 is really all about. We bring an unprecedented level of flexibility, being able to start with designs that can literally fit in your pocket at a level of efficiency that isn't matched anywhere else in the industry. Imagine an entire top-to-bottom hyper-converged stack, unmodified, that fits directly in a backpack with high availability, fault tolerance, lose any component anywhere at any time, and everything just keeps going, done at a price point that actually makes sense at every single level. See, that's what, how do I put this? That's what computing means today. It means matching the needs of business and how it's done in today's world to what infrastructure should have been all along. Let that soak all the way in for a moment. Focus your resources on moving the business forward, not on an unbelievably deep level of tools for tools to accomplish the basics. Now, in today's world, there's been quite the discussion about being green, over-provisioning in the cloud, over-provisioning on the ground in the traditional data center. Let's face it, there isn't a cloud out there that isn't wildly over-provisioned. whether it's Azure having 100% more gear than what they actually need to run, to a legacy data center spending way more money than they actually need to support 20 or 30% of their workloads. If you want to talk green, talk about right-sizing at every single individual level, not consuming more than you actually need, while still having the ability to grow on a just-in-time basis and not being tied to the infrastructure you already have in place from a technical requirement perspective. Being able to take the next increment of growth based on the latest technology simply by Lego block style snapping in a new, even faster piece. It's that kind of dynamic flexibility that we're bringing to the table for you folks. From the edge, to the fog, to the cloud, and the core. This is what scale computing is really all about, is giving you an entire top-to-bottom infrastructure that lets you not have to think about your infrastructure, that's inherently protected from multiple levels of attack surfaces. But you don't require experts to run in places where you just, let's face it, don't have experts. That's automated in a way nobody else can quite get to. So let's talk about tying those pieces together. Imagine that you're a large retail chain. Grocery stores, for example, or maybe a shipping company. Doesn't really matter which. Maybe a manufacturing company or a foundry. You've got sites galore. You need to implement a solution that runs from the edge all the way to the core and everywhere in between. You don't want to roll trucks. You don't want to have people having to manage tons of VPN connections and jump through hoops to do the basics. You need that control plane that ties it all together. That control plane allows you to do things like, scan a box, ship that to each of the individual stores where it needs to go to, and that barista, that store manager, is able to take that device out of the box, plug in power, click in a Cat6 cable, hit a power button, and walk away. That device already knows exactly how to call home, how to configure itself, how to grab its workloads, come up, come online, and go to work without anybody having to do anything else. That automatically can survive component failure, lose any node anywhere at any time, lose any drive anywhere at any time, and everything just keeps going. That firmware updates, those chasing it around through all of the different possible permutations, they become non-events. Firmware updates for each individual site at the click of a button from a single pane of glass that non-interruptively, non-destructively updates things at every single level. Those are the kinds of things that scale brings to the table for you. Now, how does that tie to optimizing and monitoring IT infrastructure? It gets rid of the need for building tools on tools on tools and shopping for some other tool to make this tool work with that tool to work with your workloads. It's built from the ground up to work directly at every single level. That infrastructure management. At a glance, I can see what's happening at all 6,000 of my stores, all 10,000 of my sites. With the things I need to pay attention to already bubbled to the top for me, and in most cases, automatically remediated without me having to do anything. Certainly without me having to roll a truck. Now, what does this all boil down to? Infrastructure has changed. The definitions have changed. Where business is done has changed. Don't be trying to play catch up from how things were done 5 or 10 years ago. Start by rolling out something that lets you focus on the future, not focus on 63,268 different tools. That's what it's really all about. Thank you.
Okay, thanks, Alan. Great stuff. And we'll leave the leave your call to action slide up there for just a second. If people want to reach out to you, there's your email. But we do have a bunch of questions in from the audience. Let's see. The first one from Byron is asking, is this a hypervisor to replace VMware?
It includes the hypervisor, absolutely. Okay. You see, the point of hyperconverged infrastructure, all those years ago when we very first came out with it, back 2010, 2011, was to eliminate stacks and disparate parts from different vendors by combining them into a super infrastructure, if you will. That's actually where the term hyperconverged came from. Now, the analyst Arun Tanaja was the guy that actually came up with the term specifically to describe this approach to computing. Now, originally, hyperconverged infrastructures were targeted just at very specific workloads, but the truth of the matter is hyperconverged infrastructure, by including hypervisors, including storage stacks, including networking control, including all of the basic pieces, found themselves a perfect home in SMB, mid-market, and distributed enterprises. And as you start looking at what the edge is, you may have these major global multinational corporations with 10,000 sites. But if you drill down to each of the sites, what are they? Well, they've got a shocking resemblance to an SMB. Being able to set those workloads up on modern infrastructure that allows the placement of this application really needs to go right here because it's real-time monitoring a production line and needs to be able to kick out in milliseconds, in microseconds, defects. Now, it doesn't lend itself to cloud terribly well, does it? You can put applications where they actually need to be throughout the chain. So yes, it does include the hypervisor, but it gets rid of the hypervisor licensing costs, and it includes so very much more.
Okay, great. Thanks for that explanation.
Mm-hmm.
And I'm going to go ahead and put the poll up here for anybody for people who would like more information about scale computing. You can go ahead and enter what kind of information would be most helpful for you. And Alan, I just have to say I really enjoyed your reference to the pain multiplier and expert-free locations. That's such a trenchant observation.
You know, I appreciate that. It's funny when I look at how these tools have been built and tools on tools on tools. It's like the ultimate expression of Douglas Adams' life, the universe, and everything. It really is. You know, what's the answer? 42. Well, we got to build a bigger tool to figure out the question.
Right.
That's where we are from an IT perspective globally, and man, there is a better way.
Yeah.
We know because we built it.
Another question that came in here from a person is asking, can I use the flagship products of scale computing agnostic of the file system in my server or the cloud service providers that I use?
Of course. You see, in Scale's HC3 implementation, we don't use file systems at all. We don't need to. File systems exist inside of workloads. Workloads, whether containerized or virtualized, running as VMs, that's where file systems need to exist. Underlying that is our own proprietary block-level implementation that we built out a decade ago, Scribe, that ties directly into multiple clouds in multiple ways.
This next question comes from Eric. You know, and you made a bunch of interesting comments about, you know, the edge being sort of the new data center. And Eric is wondering, what are the primary challenges to edge computing? I know you went into that, you know, a bit during your presentation, but, you know, is there anything else you can say about, you know, what you see as sort of the primary challenges?
Outside of the scope of volume, yeah, there's lots. You've got the inherent problems associated with the fact that edge computing can be somebody's home office, somebody's cell phone, can be the actual oil field, can be where the businessman sits down face to face and meets another businessman to accomplish something. You've got multiple layers of things you need to think about there, and we've tried to do that for you, from security to connectivity to securing things all the way through the chain and giving you a place to put the workloads that need to be at each individual level in a cohesive way.
Okay, fantastic. Well, Alan, it looks like we're running out of time. There are more questions in the chat, so you know if you've got a few minutes and you can you know, check those out afterward, I'm sure everybody would appreciate it. But thanks so much for coming on. And you know, if somebody wants to get started with scale computing or find out more, what do you recommend?
You know what? Send me a note. I'll happily take some time out of my day. If you know that's a little too directly on, start at my website, scalecomputing.com.
Okay.
You see, more than just telling you, we'll show you. We'll let you get hands-on with some of this stuff.
Awesome. I did put your slide back up with your email on it, and I'll also mention, you know, to check out the Scale Computing PDF in the handout section. But Alan, thanks so much for coming on and bringing us up to speed on scale computing. Really appreciate it.
Happy to do it. Thanks again, guys.